Hey everybody, so this is my second video in the series on an introduction to the normal distribution. So in this example, we're told that the length of a nail, x millimeters, produced by a machine is modeled as x being distributed normally with a mean of 6 and a variance of zero point 0.2 squared. For part A, we've been asked to work out the probability the length of a nail x being greater than 6. So if we look at our curve, we know it is symmetrical about the average mu, so this will be 6. And we know each of these divisions is one standard deviation away from the mean. So this value will be 6.2, and this value will be 6.4. And then this one will be 6 take away the standard deviation, so 5.8, 5.6, and 5.4. Because we're looking at x being greater than 6, we're looking at the area of this half of the curve. So this will have a probability of 0.5, or half the total area under the curve. For part B, the probability of x being less than 6, well, now we're looking at the other half of the curve. So again, this will be 0.5. For part C, the probability of x equaling exactly 6, well, if we were to think about this, probability that x equals 6 is actually, it is 6.0000, so on. And the probability of it being exactly this is negligible. So we say this is 0. Part D, the probability of x being less than 6.2 but greater than 5.8. Well, that will be between this division and this division. And we know each of these is one standard deviation away from a mean. So this area will be 34%. This will be the same. So the probability will be the sum of these two, 68%, or 0.68. Okay? Let's look at example 2. So in example 2, we're told that the heights of a group of year 6 students, given as y centimeter, are modeled as y being distributed normally with a mean of 120 and a variance of 100. We've been asked to state the proportion of pupils that are between 110 and 130 centimeters tall. So the first thing we need to do is label our x-axis. We know it's symmetrical about the mean, and this is given as 120. So we'll have 120, and each of these divisions is one standard deviation. So we know the variance of y is equal to 100. So sigma y, the standard deviation, will be the square root of this variance. So root of 100 will be 10. So this division will be the average plus one standard deviation, 130. Then we'll have 140 and 150. Going back the other way, 110, 100, and 90. But to work out the proportion between 110 and 130, well, we're looking at the mean minus one standard deviation, and then the mean plus one standard deviation. So we're looking at this region. We know each of these have a region of 34, so in total, we'll have 68%. For part B, between 120 and 130 will be between the average and plus one standard deviation. We know this is 34%. And then for part C, between 110, which is a mean minus one standard deviation, and 140, the mean plus two standard deviations. So you've got 34% here, another one here, and we know this probability given as 135, so 13.5%. So the total proportion then will be the sum of these, which gives us 81.5%. Okay?